As the mid-ocean ridge pulls apart, there's decompression of the material underneath it, and that creates melting. Decompression is simply removing the pressure from a pile of rock. It's much like opening a can of soda or popping the cork off of a champagne bottle.
The removal of so much pressure makes the rock melt into liquid magma.
Now, the hotspot is transporting heat directly from the interior of the Earth to the surface, which also creates melting. So this combination of decompression of existing rock beneath the surface and the direct transport of heat from the center of the Earth create a huge amount of magma.
This incredible meeting of the mid-Atlantic ridge and hotspot began to build the island beneath the waves, pushing it upwards and giving birth to Iceland. Scientists have dated the island's emergence to 20 million years ago, but could only imagine what this might have looked like. But on November 14th, 1963, off the south coast of Iceland, the world watched an action replay of Iceland's spectacular birth. A column of rock and ash blasted out of the ocean 18,000 feet into the sky, so high it could be seen 70 miles away in Iceland's capital city, Reykjavik. A new island was forming right in front of the world's eyes. Scientists called it Surtsey, after the Norse god of fire, Surtur. Located 20 miles off the mainland, the small island of Surtsey is now a magnet for geologists. It offers a wealth of forensic evidence for Dr. Lafamina, who is investigating how Iceland first formed.
It's amazing to see Surtsey for the first time. I've seen pictures, I've seen aerial photographs, but to actually be here and get a chance to go out and see it up close and actually look at the geology, it's just awe-inspiring. This type of eruption that formed Surtsey has now been named after Surtsey. We call them Surtseyan eruptions, and they're very, very explosive. The interaction of hot magma or lava with the ocean causes these very steam-rich and highly explosive eruptions of ash and water.
When scientists first stepped foot on the island in the summer of '64, they found it hard to believe that this was an island whose age was measured in months, not millennia.
In about 9.5 months, this whole volcanic cone built up. In addition, lava flows came out of the volcanic center here, and we're seeing these nice black cliffs in front of us.
Now geologists had an insight into how early Iceland might have formed. In only 20 million years, Iceland grew from a tiny island into a 40,000 square mile landmass, as big as the state of Kentucky. The forces that power Iceland's volcanoes have been revealed. Cracks along Hekla volcano unleash gigantic fissure eruptions, and rare chemicals in the rock prove that these eruptions were fueled by two separate forces, the mid-Atlantic ridge and the hotspot. Iceland grew to become the world's largest volcanic island. But volcanism alone doesn't explain how the land of Iceland was formed. The investigation will unearth another equally dramatic force that sculpted the distinctive shape of the Iceland we know today. A force which would challenge the might of Iceland's volcanoes. If Iceland was formed by fire alone, it should look like other volcanic islands such as Hawaii or Tahiti. But something else was at work here to transform this island into the distinctive shape it is today. Its shape is another clue to Iceland's formation. An extraordinary force indented Iceland's northern coastline, burrowing deep fjords which extended far inland. But what colossal force could cause such a dramatic change to Iceland's volcanic landscape? There's an obvious suspect that's found scattered across the island: ice. As its name suggests, Iceland has a long history of being covered in ice like this. Today, it covers 10% of the island, all year round. And in the middle of the country lies Europe's biggest ice cap, the mighty Vatnajökull. Over 3,000 square miles in size, Vatnajökull is so large, it even has its own climatic conditions. Up to 2/3 of a mile thick, it squashes the land like a giant slab of rock, and at its edges, great tongues of ice flow out through deep valleys. Glacier expert Dr. Matthew Roberts is investigating how ice can gouge out solid rock and discover the role it has played in Iceland's past.
This is a GPS receiver, just like in-car satellite navigation. It's used here to measure glacier movement. This will be left on the ice surface for a few days, and then I'll come back and analyze the data and discover just how far the glacier has moved.
Dr. Roberts' data reveals that this whole glacier is sliding forward at an astounding rate of 2 feet per day.
This is an amazing, ever-changing environment. The ice around me is like an icy sea that's been frozen in place. As the ice flows out of the confines of the valley, it expands and spreads to occupy a greater area. Now, as it expands, crevasses form and large depressions, just like the one here. Here's a smaller crevasse that's formed. Occasionally, when these crevasses open, as they begin to open, sounds can be heard. Also, the glacier occasionally makes a groaning sound. This is all signs that the glacier is alive and moving forward very slowly.
Vatnajökull is one of the largest ice caps in the northern hemisphere. Flowing down the valleys, the great mass of ice bears down with the weight of 100 tons per square foot. Dr. Roberts believes this moving giant is a force capable of eroding solid rock, and he's found crucial evidence to prove it.
This is an excellent example of the power of glacial erosion. This boulder would have been trapped beneath the base of the ice, and as the ice flowed over the surface of it, it would have progressively eroded the surface of the boulder to produce these very distinctive marks called striations in its surface. We can even tell the direction in which the ice was flowing. If I take a rock, I can illustrate this. Imagine this is the base of the ice, material trapped inside the ice, being dragged across as the glacier moved to produce these very distinctive marks in the surface. This is just like sandpaper over wood, the same erosive effect.
The erosive process that's happening on this boulder is the same process that's happening on a much larger scale along the surface of these valleys.
The glacier is responsible for literally carving the landscape, producing very distinctive troughs and basins which were formerly infilled with solid rock. This really testifies to the erosive power of a glacier.
The ancient fjords on the north coast are the same deep basin shape, which means they must once have been filled with ice. Scientists now know that around 1.5 million years ago, changes in the Earth's orbit and the tilt of its axis began to cool the planet. An enormous ice sheet descended from the north and shrouded Iceland in a cloak of ice. As the ice advanced and retreated, it carved out deep fjords and indented Iceland's northern coastline. Ice was a formidable force in Iceland, and many volcanoes lay entombed beneath it. Fire and ice were now locked in a titanic battle of supremacy. Would the giant ice sheets that carved the fjords put out the fires that created Iceland? The first clue lies in this ancient valley, 5 miles west of the glacier. The valley floor is strewn with hundreds of giant boulders, but it's how they got here that interests Dr. Roberts.
These boulders provide a lot of insight into how this landscape was formed. The boulders are clustered together, and interestingly, these boulders are rounded, which shows that they've been rolling. Now the boulders have been brought together by some dynamical force. We can also see smaller boulders trapped in the centre, and it's quite clear that flowing water is the cause of this. But this wouldn't have been water in the stream that we see in the background. This would have been water produced by a much larger, faster flow that would have inundated this entire valley.
Dr. Roberts has an extraordinary theory about what happened here. In ancient times, a cataclysmic flood 100 feet high cut through this valley. It was so powerful that it rolled these giant boulders like pebbles in a stream before dumping them on the landscape. But what could create such a colossal flow of water? Dr. Roberts suspects the flood came from the mighty Vatnajökull Glacier and is hunting for clues. With such a huge area to cover, Dr. Roberts takes to the air. His investigation leads him to a crucial piece of evidence. This strange bowl-like depression on the surface of the ice.
This is an amazing location. This giant depression in the ice has been formed as a pocket of water is drained from beneath the base of the ice cap. The beautiful concentric crevasses that you see on the ice surface have formed as the ice has slowly crept into the hollow that's been created as the water is drained away.
Beneath the ice, a dynamic process is happening. Hot magma and steam are melting the glacier from underneath. The meltwater collects in a huge ice basin at the top of the volcano. The basin slowly fills, but as it does, the surrounding ice becomes unstable. Cracks appear in the ice basin, and as the hot water drains away, it forms a tunnel which channels the water to the edge of the glacier. This would suggest that volcanic eruptions still happen, even under the enormous weight of ice. Is this process the key to explaining the ancient cataclysmic flood? To answer this, we must go to one of Iceland's largest volcanoes, Grímsvötn. Lying entombed beneath the ice in the heart of Vatnajökull, this massive volcano violently erupts every 10 years. Here, fire and ice spectacularly collide, with Iceland's volcanoes emerging victorious. Ice cannot suppress the invincible power of Iceland's volcanoes, which have now found a new way to vent their anger. During a huge eruption like this, Grímsvötn can melt enough ice to fill America's largest man-made reservoir, Lake Mead. But this vast volume of water cannot be held back by the ice for long and leads inevitably to a massive glacial flood. Such a force of nature struck Iceland in 1996 with devastating consequences. The floodwater taking out everything in its path. Bridges were torn down and swept away, and the highway was submerged underwater.
The flood itself reached a peak discharge of over 1.8 million cubic feet per second. That's a remarkable discharge, equivalent to the summertime discharge of the river Amazon. Imagine that sort of condition over a relatively small area.
The sheer force of the water carried icebergs the size of 4-story buildings. It's floods like these that can change the landscape in a matter of days.
The erosive power of the flowing water can result in tremendous amounts of rock being eroded, literally being fractured away by the high water pressure that's being created. So literally a landscape can form before your eyes during a very severe glacial flood.
The story of Iceland's bizarre landscape is taking shape. Striations on rock prove that ice is a formidable force that carved out Iceland's unique coastline. Boulders strewn in an empty valley reveal cataclysmic floods of the past. And depressions in the ice confirm that Iceland's volcanoes could not be suppressed. But 12,000 years ago, the great ice sheets retreated, and Iceland was liberated from their wintry grip. Now, the effects of